Track 6, Aeromedical Factors. The examiner has covered the environment and the airplane. Now he's going to test Robin's understanding of the factors directly affecting her as the pilot.
Robin, we've talked an awful lot about the impacts of the environment and the airplane performance on our flight operations. Now, let's talk about the factors that can affect your performance in the cockpit. What can you tell me about hypoxia?
Hypoxia is basically a lack of oxygen in the body.
And how would you know if you have hypoxia?
Well, let me rephrase and add that it's a lack of oxygen in the body that results in impaired functions of the brain and other organs. Symptoms include dizziness, drowsiness, problems with judgment and memory, blue fingernails or lips, and eventually a person could black out if the oxygen level doesn't improve. It's usually caused by being at a high altitude, such as above 12,000 feet, but it can also occur as low as 5,000 feet, especially in people who have poor health, smoke, or overweight. If I have a fever or I'm on any medications, such as analgesics or antihistamines, I should look out for these symptoms, as that condition could make me more prone to hypoxia.
Now, what would you do if you think you're experiencing hypoxia?
Well, either start using an oxygen system or descend to below 10,000 feet or below 5,000 feet at night.
So let's say you did experience hypoxia and your judgment was impaired. How could you avoid spatial disorientation?
If I began to feel disoriented or confused, I would check my flight instruments and fly the airplane according to what they show.
How does hyperventilation differ from hypoxia?
Where hypoxia is a lack of oxygen, hyperventilation is a lack of carbon dioxide in the blood. When you get really stressed out, you can subconsciously start to breathe a lot faster, which can significantly lower the amount of carbon dioxide in your blood. You start feeling lightheaded, experience tingling, and then start breathing even faster as you get more nervous about it.
So, Robin, what can I do to break this cycle?
I keep a paper bag handy, and if experiencing hyperventilation, start breathing in and out of the bag, covering both my nose and mouth when breathing. This will build the carbon dioxide back up in the body. Or I could start talking out loud, which can also slow down the breathing rate.
Okay, let's talk about carbon monoxide poisoning.
Carbon monoxide is a gas that's in the exhaust produced by the engine. It's colorless, odorless, and tasteless, so it's very hard to detect. It can cause hypoxia as it affects the blood's capacity to carry oxygen, so the symptoms are similar to hypoxia, but could also include a headache. This could happen if there's a leak in the manifold or seals, and since the heater passes air over these areas, the gas ends up being pumped into the cabin and then breathed in by the pilot. Anytime I start smelling exhaust while the heater's on, I need to be alert for the potential of carbon monoxide poisoning.
And to get out of this scenario, what are you going to do?
Well, first turn the heater off, then open the air vents. If I'm still having symptoms after landing, seek medical help.
What can you do if a passenger is suffering from motion sickness?
I can open up the air vents, have them loosen their clothing, use supplemental oxygen, suggest they try to fixate on a point outside the aircraft, and tell them not to try and move their head. If one of them is a pilot, I would have them take the controls. I would make the flight as smooth as I could and terminate the flight as soon as possible.
Robin, tell me about what you know about alcohol, its use, and how it affects a pilot.
I use the memory aid 8 hours bottle to throttle. The regulations prohibit pilots from performing crew member duties within 8 hours after drinking any alcoholic beverage, while under the influence of alcohol, or while having a 0.04% by body weight or more alcohol in the blood. Alcohol in the bloodstream is metabolized very slowly, so a pilot could still be under the influence or over the 0.04% mark 8 hours after drinking a moderate amount of alcohol. I'll use the rule 12 to 24 hours from bottle to throttle, depending on the amount of alcohol consumed.
Now, Robin, I know this is not you, but what kind of attitude would someone have who didn't want to follow that rule?
Well, probably a combination of anti-authority and macho. They obviously don't want to follow the rules and may think they can take this chance without any consequences.
Good. I like to scuba dive. What should I be concerned about as far as including this hobby along with my flying activities?
Scuba diving pilots need to be concerned about flying too soon after a dive to avoid decompression sickness. For flights up to 8,000 feet MSL, you should wait 12 hours if the dive didn't require a controlled ascent and 24 hours if the dive required a controlled ascent. For flights above 8,000 feet, you should wait 24 hours after any scuba dive.
Okay, let's move on.
Although this examiner has thus far grouped like questions together, weather, performance, etc., it's also possible your examiner will choose to ask questions as the opportunity arises. For example, the examiner could ask you about carbon monoxide poisoning in the context of talking about the heating system. Try to follow the examiner's line of questioning to anticipate and therefore be prepared for what kind of information he or she is looking for. Track 7, Night Operations. Since the Checkride is taking place during the day, the examiner will need to test Robin's understanding of night operations through an oral briefing.
Robin, let's talk about factors relating now to night operations. What are some of the things you can do to improve your night vision?
There are a number of things I can do. 1. I allow about 30 minutes prior to flight to adapt my eyes to darkness. 2. Use oxygen. Even at 5,000 feet, vision can deteriorate. 3. I close one eye if I'm exposed to a bright light. 4. I don't wear sunglasses after sunset. 5. I move my eyes around more slowly than I would in daylight. 6. I concentrate on seeing objects. 7. I can force my eyes to view off-center. And finally, I keep myself in good shape, avoid smoking, drinking, etc.
Now, suppose we're on approach to a well-lit runway and this area is surrounded by darkness with no features. What's going to be an area of concern for you?
Well, I want to avoid what's called featureless terrain illusion. With no reference points in the dark, I could feel like I'm flying higher than I really am, and this can cause me to be too low. In other words, I need to watch my altitude.
Now, what kind of equipment are you going to need for a night flight?
At least one good flashlight with spare batteries. It's good if the flashlight can switch from white to red or green. The white light is used for pre-flight checks, and the red or green is good for cockpit operations.
What kind of equipment does the airplane need for VFR night flight?
And this is where I use a memory jogger called flaps. F stands for fuses. I need one spare set or 3 fuses of each kind, and they have to be accessible during flight. L stands for landing light if the aircraft is operated for hire. A stands for anti-collision light system, which is an approved aviation red or white. That's the beacon. P stands for position lights or navigation lights. S stands for source of electrical energy adequate for all the installed electrical and radio equipment. And I need all the normal VFR day flight equipment.
Now, you mentioned position lights. When do you have to have position lights on?
Sunset to sunrise.
Tell me something more about position lights. If we see an aircraft in flight and we only see a green light on it, what does that mean?
That tells me the aircraft is moving from left to right in relation to our aircraft. An aircraft has a red light on the left wingtip, a green light on the right wingtip, and a white light on the tail. If we see both green and red, then it's approaching us.
Talking about light systems, how would you determine the status of a light system, say at a particular airport?
I would check the airport facility directory and any NOTAMs. These will show what light systems are available, the light intensities, and any radio-controlled light system frequencies.
Now, how can you identify a land airport versus a sea base from the air?
Lighted land airports have white and green or green alone beacons. A water airport has a white and yellow or yellow alone beacon.
Okay, let's talk some more about colors. What color or colors are the runway edge lights?
These are white except on instrument runways where they're yellow on the last 2,000 feet or half of the runway, whichever is less, to form a caution zone for landing.
Now, how can you identify the end of the runway?
Departing, I'll see red lights marking the end of the runway. Approaching to land, I'll see green to mark the threshold.
After landing, how to identify the taxiway at night?
Taxiway edge lights are blue. Centerline taxi lights are steady green.
We covered this briefly earlier. What must you do to remain current for VFR night flight?
I need to make at least 3 takeoffs and landings to a full stop in the preceding 90 days. These have to be in the same category, class, and type of aircraft.
So when do you need to be on the ground if you're not night current?
By definition, night refers to civil twilight. This is the period a little after sunset and a little before sunrise, varying with latitude. Typically, it lasts maybe 15 to 20 minutes. But I have from 1 hour after sunset to 1 hour before sunrise to get on the ground if I'm carrying passengers, but not night current.
You know your night stuff pretty well.
Hey, thanks.
In addition to aeromedical factors, airplane equipment requirements, and airport lighting, the examiner may also test you with some night flying scenarios. Be prepared to explain how your night pre-flight inspection might differ from a day walk-around, or how your basic flying tasks would differ, including startup, taxi, departure, and navigation. Be able to explain the precautions you'd take to avoid clouds or runway incursions. The examiner needs to see how you will apply your knowledge of night operations. Track 8, Cross-Country Flight Planning. The examiner will now wrap up the discussion by looking at the specifics of the cross-country planning.
All right, Robin, let's take a closer look at your flight planning for today's cross-country. What information were you required to obtain to make this flight?
Since this flight will be out of an airport vicinity, the regs say I need to review weather reports and forecasts, fuel requirements, and consider available alternatives if my planned flight can't be completed. Also, I should be aware of any known ATC delays in effect, and last but not least, I should be familiar with runway lengths I'm going to use, as well as takeoff and landing distances for them.
What type of navigational charts are you going to be using today?
A sectional chart. I also have a VFR terminal area chart for Dallas-Fort Worth handy, and just in case I happen to need them, I have some of the adjacent VFR charts to our route of flight with me in my flight bag.
Now, just how often are these charts revised, and how do you know if they're current?
They're semi-annual, except for some areas outside the U.S. where they're revised annually. I look at the next edition schedule date on the chart cover to determine if it's still current.
Let's take a closer look at your flight log you prepared. Explain how you determined your initial compass heading for today's flight.
All right. The first thing I did was measure my true course on the chart with my plotter. Then, based on my weather briefing, I plugged the winds aloft direction and speed, along with my true course, into my flight computer to come up with my true heading as well as true airspeed. Then I found the magnetic variation off the chart and applied this value to come up with my magnetic heading. And finally, I applied the deviation off the compass card in the aircraft to arrive at my final compass heading.
Now, you've chosen 4,500 feet MSL as your en-route altitude. Explain why.
Several reasons. The first one was the hemispheric rule that says when I'm operating above 3,000 feet AGL on a magnetic course of 180 to 359 degrees, I should fly at an even altitude plus 500 feet. Other considerations were wind direction and velocity up at altitude, as well as the height of terrain and obstructions along the route. I also considered the airplane's performance as well as possible turbulence at different altitudes.
So, Robin, how did you go about selecting the checkpoints you have in your flight log?
I tried to use only the most prominent features I could find on the sectional. For example, my first 2 checkpoints are large lakes along my route of flight. Can't miss those. I also used a relatively large town and an interstate highway. To back up some of these checkpoints, I'll use VOR radials as a cross-reference.
How far apart are the checkpoints?
The first couple of checkpoints are only 10 miles apart. I don't want them too far apart to help me stay on course. At the same time, I want them far enough apart to allow for an accurate ground speed check. I shoot for checkpoints that are about 15 to 20 minutes apart flying time.
Speaking of ground speed checks, how are you going to calculate the actual en route ground speed and the ETA at your checkpoints and again at your destination.
I'll make note of the arrival time over a checkpoint and then do the same over the next checkpoint. I've already figured the distance between these, so all I'll need to complete the equation is the actual time between them. After I get an actual en route ground speed, I can then calculate my ETA over the next checkpoint and final destination.
Okay, let's talk about your fuel requirements for this trip. We've already talked about your fuel calculations, which were pretty darn good. What do the regulations have to say about the minimum fuel requirements for a VFR flight?
During the day, I need to have enough to fly to the first point of intended landing, and assuming normal cruise speed, fly after that for at least 30 minutes. At night, I need enough to fly to the first point of intended landing, and again, assuming normal cruise speed, fly after that for at least 45 minutes.
How will you file and activate for your flight plan today?
Well, I could file it in the air by radio, but it's best to file on the ground prior to departure with the local FSS or through DUOTS on my computer. Once airborne, I'll contact the FSS by radio and give them my takeoff time so they can activate the plan. I'll close it after landing by telephoning the FSS serving Abilene.
Once we're airborne, what frequency are you going to use to activate your flight plan?
I'll use 122.6 to activate. The FSS in this area lists this frequency above a blue communications box on the chart. If in doubt, I'd ask the FSS for the appropriate frequency during my pre-flight briefing.
Could you use your cell phone to activate the flight plan?
No, the FCC doesn't allow the use of standard cell phones once in flight.
Let's take a look at the chart here. When you take off, what type of airspace are we going to be in?
Well, initially, we'll be in Class G airspace up to 700 feet AGL. Then we'll enter Class E airspace.
Now, how do you identify controlled and uncontrolled airspace on the chart?
Class E controlled airspace is designated with magenta and blue shading. Class G uncontrolled airspace isn't depicted by specific coloring. Basically, if it's not depicted as controlled airspace on the chart, then it's Class G, excluding Class A, of course.
Okay, tell me about this. Basic VFR weather minimums that are in controlled airspace.
For less than 10,000 feet MSL, I need 3 statute miles visibility and maintain cloud clearances of 500 feet below, 1,000 feet above, and 2,000 feet horizontal from clouds. At or above 10,000 feet MSL, I need 5 statute miles visibility and maintain cloud clearances of 1,000 feet below, 1,000 feet above, and 1 statute mile horizontal from clouds.
Okay, how about uncontrolled airspace? What are the minimums there?
A little more complicated, but here we go. From the surface up to and including 1,200 feet, regardless of MSL altitude, I need 1 statute mile visibility and remain clear of clouds in the daytime. At night, I need 3 statute miles visibility and maintain cloud clearances of 500 feet below, 1,000 feet above, and 2,000 feet horizontal from clouds. The exception to this is when operating in an airport traffic pattern and within half mile of the runway. All I need then is 1 statute mile visibility and to remain clear of clouds.
Okay, let's talk about the different classes of airspace we're going to run across today. Will it be necessary to get Class B clearance?
No, the floor of the Class B airspace indicates 3,000 over Arlington and progressively gets higher as we proceed west, shown by solid blue lines with sectors and altitudes for each. My intention is to remain clear of Class B, and if necessary, I'll delay my climb to the final cruise altitude of 4,500 feet until over Lake Benbrook, where it indicates the floor is 5,000 feet.
Now, if you needed to get clearance into Class B airspace, just how to go about doing that?
I would contact Approach Control after finding the frequency in the legend of the sectional or on VFR terminal area charts. I'd tell them who I am, where I am, and what I want, and wait for their instructions and/or clearance to enter.
How is Class C airspace depicted on the chart, and what are the requirements to operate in Class C airspace?
Class C airspace is shown by solid magenta lines, and just like Class B airspace, its vertical limits are given as 2 numbers, indicating the ceiling and floor of the airspace in hundreds of feet MSL. Each one can be configured differently, But generally, the lateral dimensions are a 5 nautical miles radius core that extends from the surface up to 4,000 feet above the airport, a 10 nautical miles radius shelf that extends from 1,200 feet to 4,000 feet above the airport, and then an outer area with a radius of 20 nautical miles, like an upside-down wedding cake shape. There are no specific pilot certificate requirements, but it does require two-way radio communications, clearance before entering, plus my aircraft must be Mode C transponder equipped.
Okay, so how can you be certain that communications have been established when trying to obtain a clearance into Class B or Class C airspace?
If the controller responds to the initial radio call without using my IN number, then radio communications have not been established.
As usual, Robin, you're right. Now, workload permitting, the controller will indicate you should remain outside Class B or Class C airspace and stand by. So, moving on, show me an example of Class D airspace and what are the requirements to operate within it?
It's shown on this chart by a blue segmented or dashed line like this one. Class D airspace is from the surface to 2,500 feet MSL surrounding airports that have an operating control tower. There are no specific pilot certification requirements, but you must have two-way communication capability and establish it prior to entry.
Now, Robin, do all Class D airspace areas have the same dimensions?
No, Class D airspace areas can be individually tailored. Like here, if you look at the chart, we can see the Class D airspace was made to contain the instrument approach procedure. Also, the vertical limit may be different, and this will be indicated on the chart.
One more question about Class D airspace for you. What's the maximum aircraft speed permitted in Class D?
200 knots.
Does ATC provide separation services if you're in Class D airspace?
Not for VFR aircraft. On a workload permitting basis, a controller may provide radar traffic advisories, safety alerts, etc., but I'm responsible to see and avoid other aircraft, terrain, or obstacles.
As usual, you're the perfect student. Now, it's a common misconception the tower will provide separation services if you're in Class D airspace, but it's definitely not part of their responsibility. It's yours. So, okay, when the tower closes for the day, what happens to the surrounding airspace?
It will revert to Class E or Class G airspace. You can look in the airport facility directory. It indicates effective times for Class D and what it becomes when the tower closes.
Speaking of Class E airspace, what is Class E surface area?
It is Class E airspace that, as the name implies, begins at the surface. When it acts as a surface area for an airport, it's configured to contain all instrument procedures for the airport.
Are there any communication requirements when operating within a Class E surface area extension?
No, the controlled airspace contains standard instrument procedures without imposing a communications requirement on pilots operating under VFR. When operating in this area, I must make sure that I meet the minimum cloud clearances for Class E airspace, but that's the only requirement.
Okay, what's the main difference between Class G airspace and the controlled classes?
The main difference is the flight visibility cloud clearance requirements to operate within it.
If VFR flight minimums can't be maintained, can a VFR flight be made into Class B, C, D, or even E airspace?
No, but with one exception. A special VFR clearance may be obtained, provided the flight can be made clear of clouds with at least 1 statute mile visibility.
Let's say you find you need to have one of those. What would you do to go about getting one?
I'd call the tower when one was located within the Class B, C, or D airspace. If dealing with a Class E surface area, I'd call the nearest tower, FSS, or Air Route Traffic Control Center.
How about at night? Are special VFR clearances still available?
Only for instrument-rated pilots flying an IFR-equipped airplane.
Okay, to finish up on airspace, we need to cover some special use airspace. Who would you contact for clearance into a prohibited, restricted, or warning area?
Well, I can't get a clearance into a prohibited area, so that's not even a possibility. This is one here with the solid blue line with blue hatched lines. To locate the controlling agency for a restricted or warning area, I'd go to the Special Use Airspace section in the chart margin, locate the restricted area in question, and then make note of the location, altitude, times of use, and controlling agency, which is usually an air route traffic control center. Center frequencies can be obtained from several sources, such as flight service, an AFD, or a low altitude and route chart.
Okay, Robin, what is the significance of alert areas?
The significance is that this airspace could contain a high volume of pilot training or an unusual type of aerial activity. No clearance is required for entry, although it's a good idea to contact the controlling agency on its status before entering it. Information on the alert area can be found on the chart margin. They're identified on the chart by solid blue line with blue hatched lines.
Let's talk about MOAs. What are they?
MOAs are established to separate certain military training activities from IFR traffic. VFR pilots should use extreme caution when flying with an MOA. The FSS can assist in determining the status of an MOA. They're shown on the chart by solid magenta line with magenta hatched lines.
What's the difference between an MOA and an MTR?
An MOA, or Military Operational Area, is a general area, while an MTR, or Military Training Route, is a route or corridor. You can see examples of MTRs just about everywhere on this chart. These are the gray lines with a route designator. These are routes military aircraft fly to conduct low-altitude, high-speed training. The routes above 1,500 feet AGL are generally flown under IFR, and the ones below 1,500 feet are flown for the most part under VFR. 4-digit numbers indicate routes below 1,500, and routes above are designated with 3 digits. VR indicates visual route, and IR indicates instrument route.
You know, TFRs have become increasingly more important in the past few years. What are they?
Temporary flight restrictions are set to protect people and property in the air and on the ground from an existing or possible hazard. They can exist for a variety of reasons, like the president or vice president visiting an area, around disaster relief operations, and in areas where NASA is conducting operations. Nuclear plants are also an example of areas where TFRs may be established to protect people and property in the event of an accident.
Now, how do you know if a TFR affects your planned flight?
They aren't depicted on a chart, so I need to check NOTAMs to find them. TFRs are no-fly zones, so I would get all information about any TFRs along my route while on the ground and plan my flight accordingly.
Let's take a look at some of the sectional symbology. Show me some of the following on the chart. Abandoned airports.
This is a magenta circle with an X in the middle.
How about a military airport?
These are 2 concentric blue or magenta circles.
Airport elevation.
This is listed in the airport data box.
Airports with lighting facilities.
You can determine by the letter L in the airport data.
All right, how about this one? Airports with services.
By the ticked marks extending from the airport symbol.
Approach control frequencies, ATIS.
These are found in the chart margin, again in the airport data area.
How would you know the runway length?
This is in the airport data area, last 2 digits omitted.
If the runway does not have a hard surface.
By the open magenta or blue circle.
What does the dotted magenta circle mean?
An NDB.
Now, what's this magenta circle with the letter R in it mean?
That's a private airport.
You have a very good handle on chart symbology. Let's go on ahead and continue. While en route, we'll have to call to get an update on the weather and on what frequency.
Flight Watch, known as En Route Flight Advisory Service. Their primary frequency is 122.0, but other frequencies may be used to contact the controlling FSS depending on your location.
What are the standard flight service frequencies?
The controlling FSS frequencies will be listed above the communications box for that FSS. If the COM box is a heavy lined blue box, this indicates the standard frequencies are available. These are 121.5 for emergencies, 122.0 for Flight Watch, 243 and 255.4. Any other frequencies will be indicated.
Now, what if we're en route on our cross-country flight and no flight service station is nearby? How do we go about getting en route flight information?
Sometimes the FSS is remoted to an en route navade. If this is the case, I'll receive on the navade frequency and transmit on another specific one. RCOs are also available in certain areas.
Are air route traffic control centers of any use to you as a VFR pilot?
They can be. Controller workload permitting, some advisory or assistance services may be provided. Flight following is a good example. Of course, you have to know the appropriate frequency to contact them on, but you can get that from the controlling flight service or by referencing an IFR low altitude chart or AFD for the area.
An air traffic control facility can be of great help to a VFR pilot at times. It's important to know how to contact them. Now, during our cross-country flight today, tell me how you'll use radio navigation to supplement your dead reckoning calculations and your pilotage.
I'll be using the VOR to back up my navigation.
Okay, how will you determine the radio your airplane is from and a VOR station along our route?
First, I tune and identify the VOR station. Then I rotate the CDI until the needle centers and a from flag appears. And then I read the radial indicated under the CDI.
So if you're on the 270 radio from the station, where would you be in relation to the station?
West of the station.
How would you fly to a VOR station?
Tune and identify the station, rotate the OBS until the needle is centered and a to flag is indicated, then turn the aircraft to the heading indicated under the course selector index and keep the needle centered until station passage. If the needle goes right or left, I'll correct towards the needle.
And what is reverse sensing?
Reverse sensing occurs when the heading I'm flying is essentially opposite to the course selected. The CDI will move away from the selected course instead of towards it. So instead of correcting towards the needle, I'd have to correct away from it to make it center. I can avoid this situation by always ensuring that my magnetic heading agrees with the course I've selected.
Tell me, what type of reception distances can we expect from a VOR station?
Well, it depends on the class of station as well as the aircraft's altitude. Reception distances range from 25 miles to as much as 130 miles.
Now, how about checking the accuracy of your VOR receiving equipment?
There are several different ways to check. I can use a VOT, which is an FAA certified testing station, and I can also use airborne checkpoints as well as certified ground checkpoints. All these I can find in an AFD.
Here's a scenario for you. You become disoriented or lost on the cross-country flight. What will you do?
Well, the first thing is not to panic. I'll continue to fly a specific heading in a direction I believe is correct, or if necessary, I'll circle around a specific landmark. The idea is not to wander around aimlessly. If I've been flying a steady compass heading and keeping a relatively accurate navigation log, I should be able to locate my position. If several VORs are within reception distance, I can use them for a cross-bearing to determine my position. Even a single VOR can help a lot to narrow down my possible position. Another way to establish exactly where I am is fly to a VOR station. No doubt where I'd be then.
What if none of that works? What else are you going to do?
Well, by knowing my last known position, elapsed time, approximate wind direction, and ground speed, I can establish how far I might have traveled since my last checkpoint. Then, using this distance as a radius, I can draw a semicircle ahead of my last known position on the chart. If I'm still unsure of my position, I need to start doing what you call some first-class pilotage. I'd start looking for something big, like rivers, mountain ranges, prominent highways, or railroads. Once I could identify one, I could use it as a reference to get reoriented to the chart and then hopefully get an approximate fix on my position.
During all this, what are the most important actions in relocating your position?
The 4 C's. I climb, with the idea being that the higher the altitude, the better the communications capability I have, as well as a better visual range for identification of landmarks. Then I communicate by using the system. Center could be of enormous assistance if I could contact them. I could also use 121.5 if no other frequency produced results. If I were successful in establishing communications with someone, I'd confess my predicament. And last, I would comply with the instructions they provide. And if none of that worked, I would do my best to get the airplane on the ground as soon as possible. Otherwise, I'm no more than an accident waiting to happen.
Robin, that is exactly correct. Most accidents are the products of mistakes which have multiplied over a period of time, and getting lost is no exception. Never push your luck. It might be that in doing so, you'll commit the final mistake, which will add to another figure to the statistics of accidents. If terrain or other conditions make landing impossible at the moment, don't waste time. Don't search for the perfect field. Anything usable will do.
I hope I never have to use that advice.
Okay, Robin, here's our next scenario. You're en route on a cross-country flight. Weather has deteriorated and it's becoming necessary for you to divert to an alternate airport. Tell me, what procedures are you going to use?
First, I'll mark my current position on the chart along with the current time next to my mark. Second, I'll take a look at my available alternates, considering distance, and select the one most appropriate for the emergency. Third, I'll determine a rough magnetic course to the alternate and divert in that direction immediately. I've found that using a radial of a nearby VOR or an airway that closely parallels the course to the alternate is a good way to get me headed in the general direction. As I proceed, I'll compute wind correction, actual distance, and estimated time and fuel while en route to the alternate. A quick way to get a rough distance to my alternate is to place my finger at the appropriate place on a straight edge of a piece of paper and then measure the approximate distance on the mileage scale at the bottom of the chart.
All right, let's talk about some regulations affecting today's flight. What does Part 91 say about the responsibilities of the pilot in command in the event of an in-flight emergency?
The PIC is directly responsible for and is the final authority in the operation of the aircraft. Also, the PIC can deviate from any rule to the extent necessary to meet the emergency.
Now, if you do have an emergency, are you required to file a written report with anybody?
Only if requested to do so by the FAA.
How about in the event of an accident?
For something like an accident, in-flight fire, flight control malfunction, or property damage over $25,000, I'd need to notify the NTSB immediately.
And how would you go about doing that?
Look in the phone book government pages for the nearest NTSB field office. They also have a website with phone numbers for all the regional offices.
Now, Robin, what responsibility does the PIC have concerning passengers and the use of seatbelts?
I have to ensure that each person on board my aircraft occupies an approved seat with a safety belt and shoulder harness, if installed, properly secured about them during movement on the ground, during takeoff, and on landing.
Now, how about kids? Are they required to wear a seatbelt?
Yes, except for passengers that are under 2 years old who may be held by an adult occupying a seat.
Now, Robin, you're about to make a sightseeing flight in the local area. What do the regulations require you accomplish prior to the flight?
I need to get all the information I can about the flight, including runway lengths at airports I intend to use, and takeoff and landing data under the existing conditions.
Suppose you've flown over to a neighboring town and you're pre-flying the airplane now to return back home. You've noticed both fuel gauges are reading empty, but visual inspection confirms the tanks are topped off. Are you legal to make the flight back home if you placard the gauges inoperative?
No, fuel gauges are required to be working.
Okay, now let's suppose this. You lose your vacuum pump in the same type of situation. You've landed somewhere, but still need to make the flight home for repairs. Can you fly back without your vacuum instruments?
Yes, these would be the attitude and heading indicators, and neither is required by regulation under the list for day VFR equipment. In this case, I could placard the instruments and return home for repairs.
So suppose you're planning a flight over a remote area or maybe over mountainous terrain. How would you check your ELT to find out if it works?
In this particular plane, the ELT is mounted back in the tail cone behind the baggage area. It has a 3-position switch, on, off, and armed, and is normally set to armed. If I want to test the signal, I can turn the ELT on in the first 5 minutes of the hour and listen for the signal with my comm radio set to 121.5.
Speaking of flying over the mountains, when do you or your passengers need to use supplemental oxygen?
Well, I'm required to use oxygen for any part of a flight that exceeds 30 minutes above 12,500 feet. Above 14,000 feet, I'm required to use oxygen the whole time, and above 15,000 feet, passengers must be provided supplemental oxygen. But I think it's a good idea for me and my passengers to use supplemental oxygen above 5,000 feet at night and above 10,000 feet during the day.
All right, it's good to see you establish some of your own personal limitations. What can you tell me about the rules of right-of-way? Who has the right-of-way when it comes to different categories of aircraft?
To remember this, I use the acronym BAGAR: balloons, gliders, airships, airplanes, and rotorcraft. A balloon will always have the right-of-way over any other category of aircraft. A glider has the right-of-way over an airship, airplane, or rotorcraft, and an airship has the right-of-way over an airplane or rotorcraft. Aircraft towing or refueling other aircraft have the right-of-way over all other engine-driven aircraft, and aircraft in distress have the right-of-way over all other air traffic.
What would you do if you noticed you were approaching an aircraft head-on? Also, if you realized you will overtake another aircraft ahead of you, what would your procedures be?
Approaching head-on, I'd alter course to my right, and if overtaking another aircraft, I'd alter course to the right and pass well clear, since the other aircraft has the right-of-way.
And what is the minimum safe altitude that you can fly over a congested area or a city?
Except when I'm taking off or landing, I can't operate an aircraft over a congested area or over any open-air assembly of people below an altitude of 1,000 feet above the highest obstacle within a horizontal radius of 2,000 feet of the aircraft.
And what would the minimum altitude in uncongested areas be?
No lower than 500 feet above the surface, except over open water or sparsely populated areas. In those areas, I can't operate my aircraft any closer than 500 feet to any person, vessel, vehicle, or structure. At all times, I need to be high enough so I can make a safe landing if there's an emergency.
Okay, as we approach our destination airport today, who will you contact and on what frequencies?
Since I'll be in Class C and D airspace today, I'll get the approach control frequency for Abilene Class C airspace, as well as the tower frequency for Abilene Regional. I'll also need the ATIS frequency, as well as the ground control frequency. As the chart indicates, ATIS will be 118.25, approach will be 125.0, and the tower will be 120.1, and ground will be on 121.7.
So let's suppose the radio fails in flight. Would it be possible to continue on to Abilene with no communication capability?
I can't enter Class C airspace without communication capability. If my destination was in Class D airspace only, I could proceed inbound and land as long as the weather is at or above basic VFR minimums. So I establish and maintain contact with the tower and receive a clearance to land via light gun signals.
Now, give me an idea of what procedures you would use to enter the traffic pattern and land at Abilene in a no radio condition.
Well, first I'd like to say that it would be a great idea to land in a non-towered airport and try to determine the problem. If I decided to proceed, I would phone ahead and notify the controlling facility of my intentions. Then I would proceed inbound, remaining outside or above the Class D airspace, until I could determine the direction and flow of traffic if I didn't already know. Then I would join the airport traffic pattern, maintain visual contact with the tower, and look for light gun signals. I'd squawk 7600 on my transponder so ATC is fully aware of my situation.
Speaking of light gun signals, what would you do if you saw an alternating red and green light while inbound for landing?
I would exercise extreme caution, but go ahead and land unless I saw reason to do otherwise.
Now, let's suppose you're heading downwind and the tower gives you a steady red light followed a minute later by a flashing green. What should you do?
If I get a steady red signal, I want to move clear of all other traffic and circle around until I got further signal. The flashing green would then indicate I could return for a landing, hopefully followed by a steady green, meaning cleared to land.
And how are you going to acknowledge the signals from the light gun?
By rocking my wings. At night, I would acknowledge my blinking by landing light or navigation lights.
Now, is there a standard traffic pattern at a non-towered airport?
Yes, I would enter the pattern in level flight, being the midpoint of the runway at pattern altitude. I should make all turns to the left unless the airport displays visual markings or light signals that indicate right turns. When departing, I should comply with any established traffic pattern for that airport I may have found in the AFD. During my climb, I would continue straight out or exit with a 45-degree turn to the left in a left-hand pattern or to the right in a right-hand pattern after reaching pattern altitude. I'd announce my position on the CTAF so others in the area know my whereabouts and intentions.
How are you going to determine the traffic pattern, an active runway, and the wind conditions at a non-towered airport?
I would try to contact Unicom first or listen to others on CTAF, but if that's not giving me the information I'm looking for, I would look for a windsock and hopefully a segmented circle.
What traffic pattern altitude should you fly at a non-towered airport?
During pre-flight planning, I should reference the AFD to determine the correct pattern altitude. Short of doing that, I could make a radio call before entering the pattern for a possible field advisory from Unicom. If that wasn't available, then I'd use the standard pattern altitude of 1,000 feet AGL.
So, Robin, you're approaching a non-towered airport and you notice a big yellow X on the runway. What does that indicate?
The runway has been permanently closed.
Suppose we're on final for Abilene. Explain to me what some of the runway markings indicate. Let's use this diagram of a typical runway.
Okay, of course we have the runway designation, which indicates runway direction relative to magnetic north. We also have a series of chevrons indicating this section of the runway is unusable for landing, takeoff, or taxiing. There's also a series of 8 white stripes arranged on both sides of the runway centerline, which indicates the runway threshold, the beginning of the usable landing runway.
Now, what is the significance of a displaced threshold and how are they marked?
A displaced threshold is shown by arrows painted on the pavement that lead up to the runway threshold. Basically, this surface can't be used for landing because it doesn't have load-bearing capacity. It can be used for taxi or takeoff, though.
Let's say you're going down the taxiway and you come up to a red sign with white letters on it. What does that signify?
That would be a mandatory sign, which you would generally find marking an area where you either shouldn't go or perhaps need a clearance to enter. For instance, runway numbers will be displayed on the mandatory sign that appears next to the runway hold short line.
Now, what are the 2 white rectangles on either side of the runway center line?
Those are runway aiming point markings. They're located 1,000 feet from the landing threshold and serve as a visual aiming point for landing.
Okay, we're still on a long final and we have to get the following clearance from tower. Cessna 4816 Bravo. You're cleared to land runway 6 right. Hold short taxiway Bravo. Explain the significance of this clearance.
This is a land and hold short clearance. At towered airports, ATC might clear me to land and hold short of an intersecting runway, taxiway, or some other point on a runway. If I accept the clearance, I'm assuring the controller that I can land the aircraft safely and stop within the available landing distance.
Must you accept the clearance?
No, if I'm not familiar with the land and hold short operation, I shouldn't accept it. Matter of fact, the controller will expect me to decline the clearance if I feel it will compromise safety.
Okay, we're on the ground now. How are the taxiways marked?
Taxiways are designated by a single continuous yellow line.
Give me some examples of the airport signs you'll be seeing while you taxi to parking.
I can think of runway distance remaining signs, information signs, direction and destination signs.
Now, let's talk about runway incursions. What are several recommended practices concerning prevention of runway incursions?
Well, I should always read back all runway crossing and hold short instructions. I can make sure I review airport layouts during my pre-flight planning and before descending to land. Also, I shouldn't hesitate to request progressive taxi instructions when I'm unsure of the clearance given or where I'm going. In lower visibilities, I should keep my aircraft lights on. While taxiing, I should have the airport layout diagram on my kneeboard.
You are correct, and I might add that during pre-flight you should make sure to review any NOTAMs for information on runway and taxiway closures, at your intended airport destinations. Also, it's another good practice to always write down any complex taxiway instructions at unfamiliar airports.
That's a good idea.
Now, on arrival into Abilene, you'll notice you're being vectored to a final behind a relatively large aircraft. What precautions should you take?
I need to be concerned with wake turbulence, especially since I'm following an aircraft that's likely heavy, clean, and slow. If I'll be landing on the same runway, I'll stay at or above the larger aircraft's final approach flight path and make note of its touchdown point and land beyond it.
How about if you were cleared to take off behind a departing large aircraft? What procedure would you use in this case?
I would make note of the larger aircraft's rotation point and rotate prior to where it rotated. Then I would continue climbing above the larger aircraft's climb path until turning clear.
If tower clears you to take off behind a large aircraft, who's responsible for wake turbulence separation? You or the tower?
I am.
That's exactly correct. Accepting a clearance from ATC is an acknowledgement that you're going to ensure a safe takeoff and landing interval, and for you to accept the responsibility for providing wake turbulence separation.
Yes, sir.
Speaking of turbulence, where are you going to encounter wind shear?
Wind shear can occur at any level in the atmosphere, but most often in the areas such as frontal zones, thunderstorms, and in low-level temperature inversions.
What's the significance of wind shear to you as a pilot?
If I encounter a significant wind shear, it can easily go beyond my capability as a pilot, as well as the aircraft's capability to recover from it. It's particularly hazardous down at low altitudes on approach and departure from an airport.
Robin, that's exactly right. Take any report of wind shear very, very seriously. It's been the cause of many accidents, so it's definitely an operational concern for everyone. Okay, before we go fly, a couple of things I'd like to cover. Number one is you're going to be acting as pilot in command. The regulations say even though you don't have a private pilot certificate yet, you're the PIC of the aircraft during the check ride. Do whatever you think is necessary to keep us safe and legal. Also, if the need arises for transfer of control of the airplane from you to me or vice versa, we'll say your airplane followed by I have the airplane method of transfer. Okay, Robin, just one more thing. If we do have an actual emergency on the check ride, you will have the airplane and you will handle the emergency. If it becomes necessary for me to take the airplane, I'll announce that I have the airplane. The check ride is over at that point, and all we're concerned about is handling the emergency at hand. So far, you're doing great. Robin, let's go fly.
By demonstrating her operational understanding as a private pilot, Robin has instilled confidence in the examiner of her ability to pass the check ride. Again, it's important to remember that this part of the check ride is a test of your practical application of the knowledge you gained in your training. This is not a rehash of the rote-like questions you already answered during your FAA knowledge exam. From the briefing room, the examiner will join Robin on the tarmac and watch as she goes through a pre-flight inspection. There will likely be additional questions here. Once in the airplane, Robin will run through the maneuvers she's demonstrated numerous times to her instructor according to the tolerances outlined in the PTS. She'll make a point to talk through everything she does, so the examiner doesn't have the opportunity to question her motives or actions. This is particularly important in the case of the special emphasis items. While Robin will most likely start out in the direction of Abilene, flying the planned cross-country, the examiner will probably ask her to divert at some point to remain in the general practice area in order to demonstrate the required maneuvers. Upon return, the examiner will then issue Robin her temporary pilot certificate back in the briefing room, following his observations from the check ride. The permanent license will follow in the mail a couple of weeks following the check ride, but in the meantime, that temporary certificate will do the trick for granting Robin all the privileges of a licensed private pilot. I'm Matt Dragon for ASA, wishing you the best of luck with your check ride.